let's get started. I'm here to talk about ILP32 performance on AArch64. And today I want to just quickly run through a sort of a who, what, where, why, and when, but I'll replace the when with the results. And so first off, who? I'm Chris Tyler. I'm Industrial Research Chair for Open Source Technology on Emerging Platforms. That means I play around with ARM64 enterprise systems all day with my research team. I'm from Seneca College in Toronto, Ontario, Canada. I've been involved with Linaro in a couple of different ways, participating in the Connect since Connect Hong Kong in 12. So this is my ninth Connect. With my research team, we do applied research into the potential of energy-efficient data center computing using ARM and open source software. Two things to note there. The first is that we do applied research, not theoretical stuff. We're doing very down-to-earth commercial impact research. The other thing is that we are supposedly working with ARM enterprise hardware, which we're still waiting for that to arrive. I never thought in 2016 we would be saying we're still waiting for really shipping commercial systems to appear, but that's certainly the state that we're in. In terms of the what, ILP32, just as a refresher or an introduction for those who are new to it, it's a programming model. The standard programming model used on AArch64 is LP64, which stands for long and pointers being 64 bits. This little table summarizes the differences between LP64 and ILP32. Effectively, your long integers are set to 32 bits as default size, and your pointers are 32 bits as well. Now, if you've got a portable code base and you're relying on the default integer sizes defined by your compiler, you're basically doing it wrong, I would say. So the important part here isn't really so much the fact that we're using 32-bit long ints. I think the more important part is the fact that we're using 32-bit pointers. But both of these come into play. In terms of what that impacts, obviously it hits the syscall and procedure interfaces, and it touches the kernel, GCC, bin utils, and libraries. Obviously, glibc is a big piece of that. So it's got a fairly significant impact across the system. In terms of where we're doing this work, in terms of software where, we're doing it on the LEAP project. A LEAP project is a distribution which we built. It's based on CentOS 7 sources. It diverges from CentOS 7 in a couple of key ways. We didn't mean to duplicate what CentOS is doing. We, in fact, were working on this before the CentOS code was released, and unbeknownst to both projects, we were actually doing the same thing at the same time. It's our intention not to maintain this as a long-term release or a distribution, but it's useful to us at the present time, so we're continuing to use it. Both that distribution and access to our build system, which is a Koji build system, are publicly available. In terms of the physical part of where we did this work, we did it in our EHL lab, where we have about a rack and a half of ARM64 servers with 10 gig networking, SSD, SAN, NAS, power conditioning, and then we've got a bunch of testing and monitoring equipment for testing thermals, power efficiency, that type of thing. From this, we selected two platforms that we specifically zeroed in on for the testing. And then the important question, why? People, whenever you mention ILP32, people go, why? Are you out of your mind? Why are you doing ILP32? But repeatedly it was said that there's somebody out there, they want ILP32. And the question was, who is they? And why exactly do they want ILP32? Good question. We talked with the Linaro folks, and they said they weren't even sure who Y was or who they were at the last Connect. But subsequently, it became clear that there's really two whys. One is to look good on benchmarks. The other camp, the x86 camp, has been using ILP32 on x86-64 for some time to make the benchmarks look good. You could consider that cheating, But if the other side's cheating, then the hardware vendors that want to bring out ARM64 enterprise systems want to at least have a level cheating playing field. The other piece is to run old code unmodified. You could say that they want to run proven, tested, field-tried code. You could also look at that as there are some people out there with millions of lines of code that are too lazy to fix it up, and they want to run it unmodified on a AArch64 platform. In terms of what these two groups want, the first group wants improved performance. They want ILP32 to give better benchmark results than LP64. Even if nobody's going to use that in the real world, they want it to look good for the hardware test. The second group has a different set of criteria. They want minimal performance loss, meaning that if they have to take a hit in performance and not rewrite their code, they're willing to do that as long as the economics work out. As long as it's cheaper to buy the extra capacity than it is to rewrite their code or modify their code, then they're happy to use ILP32 system. So the pieces. In order to do this, we used Linaro GCC 494 with a couple of patches. We used kernel 4.3 with the November 2015 ILP32 patches. They're released by Cavium onto LKML. We also picked up the pieces that were necessary for binutils and for glibc. All of those are documented on the LEAP project wiki at leapproject.ca. We put these in a Docker container to avoid doing a full multi-arc setup. The intention was that we would have a pure Docker container, and in that Docker container we would run just ILP32 stuff. It turns out that Docker itself can't do that. It execute some things inside the container. So we ended up with a bit of a hybrid container anyways, with some LP64 and some ILP32 inside there. And then in terms of testing, what we're going to use to benchmark, we use primarily the SpecInt 2006. We also tested with the LAMP stack and some other components. So the results. Interesting piece with the results. Every enterprise system that we have in our lab is provided under benchmark embargo. High keys, not so much, but they're not an enterprise class system. Even the systems that are commercially available, there's a vendor who's going around claiming that they are the first commercially available servers. They require that you agree to not release benchmarks about the platform. That's a requirement of the silicon vendor. But also they have restrictions on how you can dispose of the machine when you are done and you've hit end of life with it, that you have to communicate with them on how that's going to be disposed. So that's not, I wouldn't really consider that to be a commercially available server, but that's the best that's available right now. So I can't give you absolute benchmark results, but I think it's within at least the spirit of the agreement and probably the letter of the agreement for me to give you relative performance of ILP32 versus LP64. And summarizing a lot of work into one picture, this is what we found, and it's fairly consistent with some earlier work that was done within Linaro. You see that there's a hit in some of the benchmarks. These are the 12 benchmarks that comprise SpecInt. What's that? The bars are the two platforms. Okay, so blue and purple are the two different platforms, and these are representing the performance improvement, or if it's a negative number, the performance degradation of that benchmark compared to LP64. There are two different microarchitectures presented here. So we've got a slight variation in the results between the two platforms. We've got actually two cases there where one has a slight improvement, the other one has a slight degradation. I think overall, if I can provide an educated guess as to what's going on here, I think the difference is really memory performance. I think that's primarily what we're seeing, not so much the microarchitectural differences. You see that we have, in some cases, degradation of up to around 6%. On the other hand, we've got some significant improvements on a couple of the benchmarks, in particular the MCF one, which is a vehicle scheduling simulation. We have a performance improvement there of over 50%. On the Omnet PP benchmark, which is a simulation of Ethernet packets within a network, we have a fairly significant performance boost as well, around the 20% mark, depending on the platform. And then the 483.XLAN CBMK benchmark, which is transforming XML documents into a number of other formats. Again, we've got a fairly significant lift there, somewhere between about 8 and 10%. So what does this indicate? Not a consistent lift, right? Definitely we have, we've got a degradation in some cases. We've got a fairly significant lift in a small number of very particular cases. And I think we can summarize it by saying this. ILP32 wins on memory utilization and cache packing when you've got a lot of pointers. Cache packing in terms of the number of data elements that you can fit within your cache. ILP32 loses when the advantage of that is overwhelmed by munging overhead in terms of either ABI or Syscall connections. Question here. Have we? No. No. Yeah. Yes?
Do you know if any of those test cases ran into the 4 gigabyte memory limit for ILP32?
No. The age of the benchmark suite pretty much precluded that. It's pretty long in the tooth. Yeah. So, in terms of the original questions that were asked, why? Two groups. One's trying to look good on benchmarks. The other is trying to run old code unmodified. I would say that to those that want to look good on benchmarks, ILP32 looks slightly better than LP64 on benchmarks. When we did some tests, fairly informal tests with LAMP stack and some other pieces, we found fairly consistent performance across the two. There wasn't significant lift, but there wasn't significant degradation either. In terms of running old code unmodified, it looks like ILP32 will allow you to use most of the performance of AArch64 without changes to your code. So that camp should be reasonably happy with the results that they can get from ILP32. But I think the more important question is this: do we care enough? ILP32 touches those 4 projects, right? It touches GCC, the kernel, binutils, and glibc. That's a lot of code to maintain across a bunch of projects.
It's way more than that. You have to look at yesterday about how it took years to get Debian built for one new architecture. This is a new architecture. It's years of work to get it supported.
As a minimum, yes, there's potentially you would have to rebuild world, right?
So if we only care about running one program and that has minimal requirements, then yes, it's only those 5 or 6 pieces. But if the question is, do we care enough to build a distro about it, then that's dozens of man years of work that needs to be done to get all the upstream projects to support this in the configure script and all that, and find the bugs, rewrite the assembly code, and all the parts that are necessary for this.
I think, though, in the two, I agree with you. I think, though, in the 2 cases that we're talking about, which is benchmarks or a very specific application, in both of those cases, it's not world that they're talking about. It's about just the libraries and so forth for that particular application or that particular benchmark. I don't see a compelling case to build a world for ILP32 for those particular pieces. Yes.
So a lot of people have asked about why don't we have a full Red Hat 7-port for ILP32? Why don't we have a SUSE Enterprise Linux for ILP32?
And it's cost-benefit ratio, right? Yeah, so the pieces, the basic pieces are there. Obviously, rebuilding world on top of that is an enormous undertaking, but fairly transparent. There's build issues to be addressed, but most of the code should come across fairly straightforward. Do we care enough to do this? That's a question that has to be left out with the community. It's really borderline. There's these two specific use cases. It probably does not warrant rebuilding world and carrying a particular distribution or doing a full multi-arc. But in those two very specific cases, there may be value. And I'm picturing that probably means appliance type devices more than it means general purpose enterprise servers. All right. Questions, comments?
Do you have an insight if there are any HPC applications which would benefit? I mean, for them it would be probably worth the effort, right? So if they would gain like 5%, then they would be willing to invest some time because that will pay off.
So HPC applications in particular are typically the ones that use a lot more memory than you can address in 32-bit mode.
But those examples, that benchmarks look to me like discrete simulations. So you have routing packages and stuff, and I could imagine that there are some use cases. And for the HPC people, they're willing to take an extra mile, to go an extra mile, right?
I agree that the memory space limitations, if you're doing large-scale computing, the memory space limitations I think outweigh the ILP32 gains in a lot of the cases.
Well, there are both things. So there are like 90% of the HPC applications use terabytes of memory, as many terabytes as you can possibly get into the servers. But there are HPC applications that don't, that fit into your L2 cache. Like if you're thinking of taking hashes from something, like there are certain HPC applications that fit comfortably into 1 megabyte of L2 cache. And you don't care about this. The applications that actually gain from this are the ones that do a lot of pointer chasing, where you have tons of pointers. And those are typically the ones that also use a lot of memory.
So yeah, so as we observe, doing this enough to run a thing is not that much work. Well, it was a fair amount of work actually, but that's been done.
It was actually quite a few months of work, more than we anticipated.
And at the moment, I think the glibc stuff isn't upstreamed, right? So yeah, so kernel and libc would still have to be upstreamed. So one place to go will be to make it possible for people who cared enough to be able to do this, is to upstream those two and configure and depackage architecture support and basically go, well, there it is. If you want to build this stuff, you can. We've made it possible. But as I say, there is also some maintenance overhead in looking after that forever if we kind of let it out. And yeah, it's as you say, it's kind of debatable. But yeah, our job really, I think, is to enable it and leave, or decide that it's so stupid we're not going to. And I don't know the answer to that yet, but.
So I think at this point we will do it. There's very little question about that. The patches that have been posted several times, they have stalled for quite a while in the past years. We weren't sure whether anybody is still interested in that. Now there is considerable interest from at least Cavium, who have continued posting the patches, and I don't see a reason not to take them into the kernel. And there are multiple reasons for why people could also get other benchmark results. So if you have a different microarchitecture, you could have something where integer math sucks on 32-bit. You could have a microarchitecture where the caches are much smaller because you have lots of CPU cores that each don't do a lot, and then you're much more constrained on memory and much more sensitive to saving a little bit of space in the memory so that you get better performance. And then, of course, there are the people that have these code bases that are known to be broken on 64-bit. Those are huge code bases, because if they weren't huge, then they would have fixed them already. And they're partly in the enterprise space. There's like banking applications from the 70s that were written on mainframes on 24-bit and then converted to 31-bit, but haven't been touched for the last 30 years. So there's quite a risk in porting them now. So it's actually, there is certainly interest on not just network switches and those things that people think about first.
The question I would have, though, is a banking application, probably, especially a decades-old banking application, probably not in C, probably not particularly sensitive
Yes.
to
And probably not
pointer
something you
size.
put on an ARM server.
One thing that there was pushback on the kernel mailing list was the inability to easily test this, to easily like just try it out and play with it. And we've put the LEAP stuff up. It's public. There's a page on how to get the ILP32 Docker image running. And so anybody that wants to just play around with the ILP32 stuff is welcome to grab that. It's on leapproject.ca, which incidentally is entirely dog food. It's running on an AArch64 server as well. So that's there, and hopefully that will maybe play a role in the debate as far as letting people test stuff and play with it. Al.
So, you ran the spec in. Did you try any spec FP or spec web benchmarks?
So we really focused in on the spec int stuff. The spec FP results were, we weren't seeing any significant variation with the ILP32 stuff. It was noise. And that was really our focus. That's why we zoomed in on the cint stuff.
Which hardware are you using for testing?
Sorry?
Hi, I came from Huawei. Why you care about these features? And I'm wondering which hardware are you using for this test?
I'm a bit nervous about actually saying which ones we use because of the don't spread benchmarks thing. But we use two readily available AArch64 rack mount servers, if that
Okay.
makes it clear.
That makes sense because we could see we are also do this similar test and we could see the similar trends about the performance impact, especially for the MCF testing. So that's okay. And do you have another plan for ILP32 in future? Next steps?
Next steps? I really think it's a community decision as to what extent this stuff is going to be supported. I don't think any distribution, well, I shouldn't speak for Debian because they seem to do more multi-arc. What's that? No.
Yeah.
But is anybody looking at doing multi-arc with ILP32? Really?
So as you say, there are people who want to be able to at least try this. So there's enough pressure being applied that I think I am about to be told to make this work in Debian so you can actually build at least a base, not a whole base system, but you know, some stuff.
Right.
So we will get the infrastructure working. But yeah, we're not going to build it all. Somebody else's problem.
Right.
And as Arne pointed out, actually, a whole load of stuff won't work without a massive amount of work to just add underscore ILP32 in loads of places where otherwise it will just go, I'd never heard of it.
Yeah.
But you know, at least if we fix configure and we fix depackage and we make sure these patches are in the core things, then you ought to be able to go ahead and build this. When you say multi-arch, do you mean Debian multi-arch or do you mean like GCC multi-lib? Because I think that's what Red Hat people mean when they say multi-arch, right?
Debian multi-arch.
Right.
Yeah.
So yeah, build it. Because I think everyone at the moment has built it as a multi-libbed compiler, right? Have you actually built it as a single architecture?
Yes.
Okay, right.
Yeah.
I shall compare notes later.
So I have a few more thoughts. So as I said, in the kernel and glibc, it's going in, basically. That's where we are. and we will probably see uptake in distributions like Open Embedded. There might be something in OpenWRT if they care. Maybe not if they don't care. We should keep pushing back on getting this into other distributions, because this really leads to fragmentation that we've been trying to avoid. On 32-bit ARM, the classic ILP32 mode, we have had a problem with too many incompatible ABIs. We've had the OABI, we've had Big Endian, we've had Little Endian, we have EABI, we've had ARMHF in multiple variations. They're all mutually incompatible. Some work on those CPUs, some work on other CPUs. Sometimes you can link them at runtime, sometimes you cannot. It's a big mess. And I would be very cautious about having additional ABIs in general purpose distributions. And that goes for ILP32 mode just as it goes for Big Endian, which has a lot of the same requirements. There's a lot of code that is known to work on Big Endian architectures and has known problems on Little Endian architectures, and that's why we support Big Endian mode in the kernel, but we don't support it in general purpose distributions. And this will, I think this will be the same way. I hope we will not see it in Debian upstream. There will certainly be people who try it out, and it would be good to have it, like, have packages available that you can play with it, but not on the Debian servers. And of course, all the RPM-based distros won't do it because they can only have one multi-lib target, and there's already several of them too many.
Very quick comment, sorry, on the benchmarks. As Mark alluded to, it'd be a very good idea to have a look at the PMU counters, in particular because one of those benchmarks will actually give a very good performance improvement if you change the alignment of the memory from the C library. And that is sufficient to give you a big sway on one of those benchmarks. So give the PMU a quick go as well when you can.
All right.
Well, we're at an interesting juncture in embedded at the moment, well, mobile, where we have lots of Cortex A53s coming down the pipe. They're very cheap parts and they're going to target 2 gig phones. Do you feel you've learnt enough that you could advise colleagues in the mobile group to port Bionic?
No, that would be insane. If you have a Cortex A53, anything in mobile will support AArch32 mode. You already have a 32-bit mode that you have to support. There's nothing to gain from having an additional 32-bit mode. This is 100% about CPUs that do not support AArch32 mode. AArch32 mode.
I disagree. An OEM that's shipping an AArch64/AArch32 compatible V8, capable V8, may use this to publish good benchmarks.
Okay, the benchmark, yes.
Yeah.
But mobile is like,
Right.
if you're talking mobile, it's Android. You would not have a full Android port to an architecture just to publish a benchmark.
I think we're at the
Doesn't
end of
that
our...
imply that, I mean, it only makes sense if your LP32 benchmark's better than your ARM32 benchmark? Have you done those? Is it actually?
No, I have not done
Or is it
that.
just because you can call it a 64-bit benchmark? I mean, it doesn't make any sense, right? It's the same API.
I think we're at the end of our time. Thank you.